Hello students, my name is Rohit and I welcome you all on this YouTube channel, Easy and Smart Chemistry. Today in this lecture we will discuss about the noble gases and the elements of noble gases and the ionization energy and electron affinity order of noble gas elements. And after that we discuss about the most important part, the reaction part of noble gas elements, and we will see that which type of elements do reaction and which type of elements does not do any reaction. Okay, and at the end we will discuss about the compounds and their geometry, shape, hybridization and all. So let's discuss about the noble gases, or its another name is inert gas. So first of all, let's talk about in which group of periodic table these noble gases are occurred. So in group number 18 of periodic table, the noble gas elements are occurred. ठीक है, understand? Now the general electronic configuration of noble gas elements is NH2NP6 except this helium. Helium electronic configuration is 1s2. Why 1s2? Because in helium there are only 2 electrons. In helium there are only 2 electrons. So like we start filling of electronic configuration electrons from S, P, D, F subshells. According to energy level we fill the electron. So as helium has only 2 electrons and S occupy 2 electrons, so for helium has no further electron, so that's why its electronic configuration is 1s2. Okay, now what is these 1 2 3 4 5 6? So it's just nothing but this is a period number: period 1, period 2, period 3, period 4. So these are the period number. Like helium is situated in first period, so its electron configuration is 1s2. Neon is situated in second period, so its electronic configuration is 2s2 2p6. From neon to radon, all the elements have electronic configuration nh2 np6. And what is this n? This n is the period number. Like after that, argon, krypton, xenon, radon. So how many elements occurred in noble gas or inert gas? So there are only 6 elements till now in the periodic table that are in inert gas or noble gas. Understand? Radon is a radioactive. Why it is a radioactive? It is a radioactive and due to this it does not participate in any reaction. So at the end we have only these 5 elements for which we have to study further. Okay. Now after elements we come to the ionization energy and electron gun enthalpy of inert gas family elements. What do you mean by ionization energy? Ionization energy means the amount of energy required to remove an electron from outermost shell of isolated gaseous atom. Okay, and these metals have high positive ionization energy. Why high positive ionization energy? Because as we discussed earlier, its configuration is ns2np6, and in n there are in S there are 2 electrons. Capacity S contains the capacity of 2 electrons. P contains the capacity of 6 electrons. So S and P, these both are fulfilled, and that's why its ionization energy is high. High endothermic energy. What do you mean by endothermic process? Highly endothermic process. Endothermic process means the energy we give to remove an electron from outermost shell of isolated gaseous atom. And that's the reason mentioned here, because noble gases have stable, and removal of electron from a stable element is tough, so high amount of energy is required. Okay, now let's talk about the electron gun enthalpy. What do you mean by electron gun enthalpy? The electron gun enthalpy means the energy released when an electron is added to outermost shell of isolated gaseous atom. Whenever we add an electron, the energy is released. Okay, all elements have negative electron gain enthalpy, but noble gas have positive gain enthalpy. Why positive? Because it's already fulfilled, and to insert an element in already fulfilled electron configuration is tough. Same reason noble gas have stable configuration. So what is the conclusion from these two topics, or from these 2 points? Noble gas have highly stable configuration. Noble gas have highly stable configuration. Now let's talk about the reaction of noble gases. So helium, neon, argon do not show any reaction. Krypton and xenon show reaction. Like only 2 elements in the noble gas show reaction. Now let's see about these 2. Krypton form only one compound, KrF2. KrF2. Krypton form only one compound, KrF2. Now let's talk about the xenon. So xenon form compound with electronegative atoms like oxygen and fluorine. Xenon only form compound with oxygen and fluorine. Now let's talk about the reaction part, like how xenon we perform with how xenon behave when it reacts with fluorine, or in which, and the conditions in which the different type of compound is formed. So xenon with fluorine, when xenon is in excess, then xenon is in excess and it reacts with fluorine, then it forms xenon F2. When fluorine is in excess, then there is 2 conditions. Condition number 1, when fluorine is when xenon ratio is 1 and fluorine ratio is 5. Condition number 2, when xenon ratio is 1 and fluorine ratio is 20. So in these different 2 conditions, different compound will be formed. When xenon is 1 and fluorine is 5, then it forms xenon F4. When xenon is 1 and fluorine is 20, like if 1 ratio 20, then it forms xenon F6. Another way is when xenon react with fluorine at 673 Kelvin, then it forms xenon F2. When xenon react with fluorine at 573 Kelvin, then it forms xenon F4. And when xenon react with fluorine at 873 Kelvin, then it forms xenon F6. Okay. Now xenon F6 can also prepare by xenon F4. Xenon F6 is also prepared by another method, like xenon F4 प्लस में O2 F2. When xenon F4 react with O2 F2, then xenon F6 is formed and O2 is released. What is O2 F2? So O2 F2 is a good fluorinating agent. It's a fluorinating agent, and O2 F2 will add fluorine to xenon F4. Like in xenon F4, O2 F2 will add fluorine because it's O2 F2 is a fluorinating agent. So xenon F6 form plus में O2 is released. Understand? Now let's talk about the hydrolysis reaction of xenon F2, xenon F4, xenon F6. What do you mean by hydrolysis reaction? When any compound is formed, when any compound is reacted with water, then that reaction is known as hydrolysis reaction. So let's see how different compounds behave when it reacts with water. So xenon F6 react with water, it forms xenon O3 plus में HF. Xenon F2 when react with water, it forms xenon plus में HF plus O2. When xenon F4 react with water, it forms xenon plus xenon O3 plus HF plus O2. So these are the different type of reactant we get, different type of results we got when these compounds are react with water. Okay, and it will be directly asked in the paper that what will be the product form when xenon F2 react with water. Then you just simply mention xenon F plus में HF plus O2. Okay, now let's talk about the structure, hybridization, geometry, shape of a molecule. Like we have different type of compounds, xenon F2, xenon F4, xenon F6, and regarding these are formed by partial hydrolysis of xenon F6. So and this portion we cover in the next lecture. So till now we study about all these three compounds, like how they react, how they form, and all this. So let's talk about that. Like if we talk about xenon F2, and in the question is regarding the find the geometry, find the hybridization, find the shape of and the number of lone pair. So basically this topic is from chemical bonding chapter. It is from chemical bonding, but we cover the chemical bonding concept also in this lecture. So this video is really helpful for you. Like in xenon F2, so there is a trick of calculating the hybridization. Just first, the step number 1 is calculate the valence electron. In xenon the valence electron is 8. Valence electron simply means number of electrons in outermost shell, and in fluorine the valence electron is 7, but there is 2 fluorine, so 7 into 2, 7 into 2 14, 14 plus 8 22. So in total the xenon F2 has 22 valence electron, and according to our trick, if there are elements less than 8, then we divide by 2. If it is from 8 to 56, then we divide by 8, and if it is more than these, then divide by 18. Simple. So here we got 22 valence electron, so simply we divide by 8, and by dividing by 8 we got 5 in quotient. 5 means 5 is what? 5 is hybridized orbital. 5 is hybridized orbital. And 5 means sp3d. When s orbital is occupied, 3p and 1d is occupied. sp3d, and sp3d geometry is trigonal bipyramidal. sp3d geometry is trigonal bipyramidal. Now talk about the valence electron. So valence electron means hybridized orbital minus surrounding atom. Surrounding atom means this fluorine. What is surrounding and what is central atom? Central atom and surrounding atom is very clearly we define from any compound. The number of atom which is least, the atom which is least in number is central atom and rest is surrounding atom. So here surrounding atom is fluorine. So hybridized orbital minus means surrounding atom. Surrounding atom is 2. So 3. So we got lone pair. So we found lone pair. We found geometry. Now what? Shape. And for shape there is simple a trick in chemical bonding we study also. I make a separate video regarding this. The shape is linear. Xenon F2 shape is linear. How we find shape? We don't need to find it. There is a trick. If we have 5, in case of 5 hybridized orbital and 2 lone pair, then what is the shape of a compound? So it is linear. Okay. Now let's talk about the xenon F4. Simple way. First, step number 1, valence electron calculation. In xenon we have 8 valence electron. In fluorine 7 valence electron. There are 4 fluorine. So we got 28 fluorine valence electron plus 8 xenon valence electron. So in total 36 valence electron. 36 is what? It is in the range of 8 to 56. So we divide by 8 and we got 6 hybridized orbital. 6 means 1 as 3p 2d. Okay, so its geometry is sp3d2. Geometry is octahedral. If the hybridization is sp3d2, then its geometry is octahedral. So what about the number of lone pair? Number of lone pair is what? Hybridized orbital minus total number of surrounding atom. So surrounding atom is 4. So valence electron is 2. And what about the shape? If we have sp3d2 hybridization or 6 hybridized orbital and 2 lone pair, then in that case the shape is square planar. Okay, the shape is square planar. All these things we study in this video is directly asked in the JEE Mains, JEE Advanced, NEET or any other paper. If you got any question from Nobel cases, then you definitely got from these concepts directly. They directly ask you that what type of product is formed when xenon F6 react with O2F2, xenon F4 react with O2F2. What type of product we got? What is the hybridization of xenon F4? What is the hybridization of xenon F2? All these things. What is the general electron configuration of Nobel gases? Ionization energy of Nobel gases? Electron affinity of Nobel gases? All these things directly asked in the questions paper. So thanks for watching this video, and if you have facing any type of doubt,